John Ernest, but you might know me as InternetJanitor. I created Octo, a browser-based IDE that lets you create games for Chip 8, a virtual game console from the 70s.
Why don't we just use Everdraed's version?
Yeah.
Hi, I'm Everdraed, posing as John Ernest, but you might know him as InternetJanitor and me as Everdraed. I created Octo, I being him, a browser-based IDE that lets you create games for Chip 8, a virtual game console from the 70s. This October, I, meaning him, helped organize October, the first ever Chip 8 GameJam, and participants created a whole bunch of fantastic programs. Tonight, my friends John and Everdraed, that's me, will be joining me, that's him, to showcase the entries and talk about what makes them tick. This is John Terp, speaking from Everdraed's mouth. We're doing a wonderful showcase of all the incredible entries to the October Game Jam, which was headed by InternetJanitor, who invented Octo, a Chip 8 emulator for your browser. Incredible! Fun! Let's look at these games!
Ooh.
Yeah. Let's look at these games. I'm just gonna head into it.
All right, let's go.
Are we linking the stream to people?
No, we're not. So this game, the first game we're playing is Chiptunnel, and I guess I'm already playing it.
You're deep in it, baby. Actually, you've gotten a head start, so get ready. You're in the danger. Oh,
Ooh.
Yeah, I messed it up. Oops.
Yeah, the thing about this game is it starts out very, very easy, and it gradually becomes almost impossible. This was made by Todd just in like the evening before the Game Jam shut down, so it is pretty simple, but it illustrates a couple of interesting ideas. Probably the most important thing to note about this is that this is the smallest, in terms of bytes, game that was submitted. And the way that it's handling the scrolling is it's not actually scrolling the screen. It's progressively, just a column at a time, updating the walls. If you look carefully, you can see a little flicker as it's redrawing each section. What do you guys think of this?
This is hard. I can't talk and play at the same time.
It's I enjoyed this game, but I thought it was a little slow to get to the point of the actual difficult game aspect of it. So, there's a really long period of time where you have pretty much you just stay still. And then you eventually get to the point where it's super constricted, and then it's pretty much you have a pixel or two of leeway. And it took so long to get to that point that you're not really... It just suddenly becomes very difficult because you only have the pixel or two, and you don't build up skills to deal with that. So I thought mechanically, it kind of showed this, like, it needed to have longer stretches of more difficult, but not as tight sections.
And of course, the other thing is that, you finish the game and you have no idea how long you lasted. So I think a good addition to this probably would have been to keep some kind of a score. But still, considering that it was made in very little time, I think this is a good approach.
Yeah, it's solid mechanically. I think it just needs to be tweaked out, and that's obviously an issue of not having enough time to bring the core concept further. But as a core concept, it works. It's a tunnel runner, and that's a cool, fun gameplay.
All right. I am done with this game. We're gonna move on.
We're gonna blast through these. Another problem was that the oops is often unreadable because of the columns. The oops.
Yeah, I think it's just drawn in a fixed position.
Yeah, so the oops could have it needs to automatically check which lines are already filled in, and then account for that, because you can't always see that it's oops. And sometimes it actually looks like it just the road is messed up or something. So something to keep in mind.
You also don't actually have to move for most of the game.
Yeah. Oh yeah,
I think if there was a scoring system and there's a leaderboard system, this would become a hell of a lot more fun. All right, moving on.
Yeah.
Cellular automata.
It's cellular automata.
I don't know what's going on here.
So this isn't so much a game, right? This is a program.
Yeah, this is more of like a tech demo. So this was made by Sharp and Spoon. He's the guy who created this website. This is demonstrating what's called a Wolfram rule cellular automaton. Basically, you have rows that represent generations, and every square in every row is determined by the squares that immediately precede it, the previous row. So basically, as you calculate successive rows, they're updated with a pattern, and what determines the pattern you get is this rule number. You can see it's drawing these, sequences of generations with different rule numbers, and every rule number shows something different. There are 256 possible rules, and this one will gradually cycle through all of them. There are a handful of these rules that are kind of interesting. There's even one that is provably Turing complete. So that's capable of computing anything that a computer can, provided you have a wide enough space.
That's awesome.
Yeah.
It is way over my head.
Yeah, well, the thing that's interesting about how this is implemented is that you can see it's going really, really fast because he has the emulation rate cranked all the way, but it's actually using drawing a single pixel to test the previous pixels on the screen. It uses the frame buffer to store the state of the automata. So this is sort of a cute little trick to save yourself some RAM.
Which is absolutely necessary on the Chip 8 platform.
Yeah, and so I said that chiptunnel was the smallest game. This was the smallest program, clocking in at only 150 bytes.
Dang. It has such pretty graphics. It's mesmerizing.
Yeah. It shows a good example of how interesting, complex behavior can arise from very simple rules when you're programming.
That is awesome. Let's move on.
Sure.
Pumpkin Dress Up.
So this was one of a trilogy of games made by System Logoff. So this was intended to be a parody of Newgrounds games.
Blip, blip, bloop.
Uh-huh.
So you may have played some Flash dress-up games before. And this is, to my knowledge, the first ever example of a dress-up game made for the Chip 8 system. You can customize your pumpkin however you want.
I've never played a single dress-up game. Never once dressed up in anime in the frilliest of clothes. No, not even once. So I really can't understand the desire to make such a game, or how tantalizing it could be to see an anime pumpkin in a frilly dress. But this is a very good example of a dress-up game that I'm completely unfamiliar with the genre, though. But this seems like a very solid example of one.
I think this game took him about an hour and a half to make. So it's definitely an example of how it seems like the tools are pretty good and easy to use because he was able to just throw this together based on a funny idea he had.
Awesome.
I kind of have a problem with some of these shapes because these would be impossible. I think the tongue wouldn't be possible on a pumpkin. So that's sort of it doesn't really fit.
You're a harsh critic.
Well, just there needs to be a certain cohesiveness. This is obviously a pumpkin, and it's not. I mean that face is impossible. Some of these are simply impossible.
Well, the one thing that is cool about this is it's actually running at a realistic speed. So you see those slow refreshes and everything. This is running at a realistic speed with a realistic RAM profile, and this program would probably work fine on an original Chip 8 system. That's actually the case with all of System Logoff's games.
What a spooky Halloween this would be if you're. When did people actually have Chip 8s and were using them as like a consumer?
Well, I think that the copyright information on the manuals that I was looking at was 1977. I think that they were sold either at the end of that year or early 78.
So spooky 77, maybe 78. You get the really spooked up Halloween. You get the spider webs. You have it all over your Cosmac VIP. And
just imagine
you load up this program and you see this pumpkin and you're just ready to go. You can change the mouth and the eyes and the nose.
And I'm sure that every single one of the 1,374 bytes that you would have had to punch in on the hex keypad would be worthwhile.
So there's no way to put it in other than to put in.
Well, you can save it to a tape after you've typed it in.
Totally worth it. I think it's absolutely worth it for that Halloween.
Okay. Let's move on to the next game.
Sure.
Sounds good.
Rockto.
This was Subsuper's game. Subsuper is probably best known as the XCOM guy, the Open XCOM guy, I should say. And this time he recreated a classic. You definitely need to be sure that you play all the levels here, John.
What is the original, like the absolute original implementation of this gameplay, like these mechanics? What's the name of that game?
I'm pretty sure that Boulder Dash is the original.
So this is Open Boulder Dash by Subsuper. He's actually leading up the open source. I mean, this is completely open source. You can look at the code and modify it. So this is Open Boulder Dash for anybody who wants to make some modifications to it.
So probably the first thing that you'll notice about this game compared to the other ones that we've seen is that it's using twice the resolution. This game makes use of something called Super Chip, which is a set of extended instructions that sort of layer on top of the normal Chip 8 instructions. These were all added to the Chip 8 interpreter that was developed for the HP 48 calculator. Oh, you're screwed.
Done.
So bone. So, to my knowledge, there are 6 levels of a sort in this game. Be sure you're thinking ahead, John.
I'm pretty sure I got stuck on this level and couldn't beat it.
So the way that the
Can I push boulders?
you can.
Can you push them if they're in a
But-
row? Can you push them to one side if you've cleared out the dirt on either side?
No, it works sort of like how Sokoban does. You can only push unobstructed objects.
I can't
So the-
push this.
You need to do something before you can take those gems. The way that this game stores its levels takes up about 112 bytes a piece. And so based on the size of the game engine and the graphics and everything that go into this, I calculated that it would have been possible to add about 17 more levels if SUP had wanted to. But an interesting thing about them is that the way that those levels are accessed is basically by setting the I register, this is a memory index, to the beginning of the first level and then repeatedly incrementing it by 112 bytes each time. What this means is, and you have to do this to fetch every single tile of the map. So what this means is that it'll be a little bit slower at drawing every progressive level. So if you had 17 levels, it might add up to a noticeable difference. This is sort of related to just in general, in Chip 8, it is difficult to do multiple indirection. It's kind of a pain, but there are some techniques for getting around it, including self-modifying code. We'll see a couple of examples of games that use that technique. Seeing some advanced strategies here now, John. You're cracking this game wide open. Oh, you didn't fall for it.
Oh, but is he? Oh, he did. He did it.
Wow. Well, second try, right?
Don't patronize me.
Little known fact that John is actually the Boulder Dash champion of the world, so he should have no problem with this.
At least of this game jam.
Between a rock and a hard place, huh, John? Can you
Tension is palpable.
Can you block the door with the rocks and make it unwinnable?
I think it is possible to do that, but in this level, he's still okay.
Yeah, I mean, he's fine now. I was just wondering if it didn't really behave correctly.
Yeah, the game doesn't detect when you're in an unwinnable situation. You just have to decide to hit reset. That's the way that most games like this work. While this game was under development, I saw a version that had a pretty funny bug where if you created a level that didn't have floor on the bottom or top, the game engine would cause falling objects to keep wrapping around in sort of like a Portals effect.
I bet you can make a pretty scenic...
How many levels? 5?
Yeah, there's one, well, there's kind of one more level. You'll see.
Mm-hmm.
Yeah.
Whoa.
So now you get to see the fact that all of the game code, actually, it looks like pieces of the title screen immediately follow the last piece of level data in the game. There's a couple ways to die in this level, but as far as I can tell, it doesn't contain an exit, so it's not possible to win even if you get the single gem.
Well, at least you have some friends down there.
I mean, I saw an exit.
Yeah, but some of those aren't real exits. It's simply interpreting the bytes that make up other portions of the game in an attempt to render them as images.
That is super interesting. I win though, so congratulations to me.
Yep.
It's a cool game. Let's move on.
Yeah.
Good implementation of Boulder Dash in the Chip 8 system.
For sure.
Rockto.
Octo, a Chip 8 story.
So
The description here says you're a developer interested in making games and you see the Octo-Jam starting up. You decide to make a game, but the question is, how will it turn out?
So as far as I'm aware, this is the first ever visual novel created for the Chip 8 system.
This is truly revolutionary. This has never been done before.
This is another of System Logoff's games. You'll notice because it has a lot of bitmap graphics in it.
You're going a little quickly through these game options, man.
What?
You'll notice that
on the code.
on the title screen there are little indicators that tell you how many of the endings you've found. So this one is interesting because this weighs in at 3,581 bytes, leaving 3 bytes of chip 8 RAM free. And of that, only about 512 bytes are actually the code. It's almost entirely uncompressed bitmaps, and those just eat up a ton of space. They're 256 bytes for every screen.
Wow.
So doing general purpose bitmap compression and doing it fast is pretty challenging on this platform, and it's sort of an open problem. So this is about as extensive as a bitmap graphics driven adventure game can get. This is a reason that you might want to augment chip 8 with some more RAM.
Very
and again,
interesting. I got all the endings.
Well, chip 8 became popular again.
Sure did.
That's the golden end.
As it should be.
Oh yeah, does Super Chip have still have the
All right.
2 palette limitation of normal?
It does. Super Chip expands the resolution. You can have twice the resolution as before. And if you had a full screen bitmap, that would take up an entire kilobyte, meaning that you can only have 3 full screen bitmaps and then a little bit of space left over for code. It also adds some scroll instructions, which I don't think any of the games this year made use of. And then there are also a few other little goodies that I can point out when we see them.
Alrighty, let's move on.
Sure.
Glitch Ghost by Jackie. I'm terrible with names. You'll have to read it when you see it. Jackie. No, I'm even going to attempt it. No.
Might be Kircher.
Kircher?
Might be Kircher.
Really? Kircher?
Kircher?
You're afraid to say Kircher?
I'm sorry if we're murdering your name here.
It's Kircher. I'm not gonna. It's Kircher. Okay, let's just go with Kircher.
Like the Ashton?
Sure.
Moving along, this is definitely my favorite game. As you'll see when you play it, it is quite extensive and has a lot of polish and really nice little touches.
Yeah.
Glitch Ghost is the only ghost in the cemetery.
It even has a storyline.
Help them make some friends.
As far as thematics, as far as being unique mechanics and tying it in, this is an Octo-Jam, and it's just about making chip 8 games, but to actually have Halloween, have some sort of ghosty Octoberish sort of theme is like going above and beyond. And not only does this have a theme that it ties the game to, the mechanics are entirely based around that theme, and it just makes a lot of sense, and it's really unique. And I think specifically its puzzle design is really interesting because not only are each screen essentially of the cemetery has a puzzle that is trying to get a guy into a grave. And to get a guy into the grave, you spook them. When you haunt them from a direction, they run in the opposite direction. And when they hit a barrier, they make a clockwise change in direction. So not only is each screen a puzzle in itself, but it's sort of a puzzle getting them to each screen. It's like a larger puzzle just trying to get them onto each new screen, because you need to populate each one starting from the first screen. So that's not necessarily an easy thing to do for some of these screens to go left or right. So I thought it was interesting, just the core mechanics of each screen kind of ties into a larger puzzle of the game itself.
Yeah, this actually feels like a real game.
It is. Totally. Let's talk a little bit about that glitch effect when the ghost activates and scares people. So you can't just take a random number and draw it as a sprite in chip 8. You need to be drawing a sprite from somewhere in RAM. So what this game does is it actually uses some arbitrary portions of the game's code as a source of some random patterns of just bytes to draw. And so it just marches through memory for a little while and draws some scrambled code on top of itself. And then after a timer elapses, it clears the entire screen, and then you see the game pick back up. This is a little bit similar to a technique that Yar's Revenge for the Atari 2600 did. It needed a source of random numbers to fill the neutral zone, and so it just used portions of the game's code for that.
This is really hard.
Yeah, so it's
It
not
is.
an easy game by any means. Like some of the
It's a legit puzzle
Yeah.
game.
like it's actually kind of difficult just getting to a screen that is unfilled at that point. And then once you're at the screen, it can be very difficult to figure out exactly where you need to position the ghost. It's not an easy game. For a chip 8 game, I think it gives a really significant amount of challenge. Because I know it took me like
Yeah.
15 minutes at least to get the final person to the last grade. I think
Easily 15 or 20 minutes of gameplay, which is very impressive, given the memory limitations that
I
you're
mean, for
working with.
puzzles, which is entirely based on having like unique designed levels that you have to like put in yourself. It can't be like sort of beating like a timer based thing. It's this is content that you have to put in. I think they did a great job with this. I think I had a single complaint about this game, and it was that the ghost's hitbox, which is what determines it stops the player so when the player hits the ghost, he will also change direction like you are an obstacle. But the ghost sprite changes. You can see it kind of going up and down, and the dash below it changes.
Yeah, bobbing
So
in the air.
those are all hitbox changes for the ghost, which makes accurately predicting when you're going to block the human kind of difficult. In one sense, like the body of the ghost kind of stays relatively the same. I guess it goes up and down one space, but it's hard to be precise with exactly knowing where the hitbox is going to lie for that when a human is about to hit you.
It's really mainly a problem when you're trying to block something with the top edge of your ghost. I don't know how many of the puzzles actually require that. I know that there are multiple solutions to some of these.
Oh yeah, I mean, there's ways that you can kind of get inside the human, and if you time it just right, you can completely destroy a puzzle. But it takes a really like a superhuman. It's pretty much luck. I think if you were like superhumanly skilled and knew exactly what to look for, you might be able to do it. But
that was so close.
So it's a lot about generally you'll find a loop that the human will get stuck in, and by one more interaction, you'll be able to get him into the grave. So it's like understanding where you have to be spacing wise for that loop to work out to be sending him to the grave.
So I've mentioned emulation speed.
Really
He almost had
I mentioned emulation speed in a couple of these games, so this is one of the games that runs at a slightly faster speed than is really realistic for the original hardware. This is running at about 200 cycles per frame rather than 730, which is roughly the speed that we assume that the original system was at. But what's interesting is that most of this game will run at a realistic budget. Mainly, it's just that ghost scare animation thing that ends up pushing it over. And I looked at the code. There are a few relatively small changes that could be made that would probably get it running realistically on a real system.
Awesome.
I did exchange a few emails with the author, and understandably, she's pretty sick of working on it after a whole month. But
she did a great job. I think she did a really fantastic job. It's awesome that like I could understand the method to create that effect would be kind of taxing. Just knowing that this could realistically, with that being tweaked a bit, this could work, completely fine on an original chip 8 system. That's really awesome. Because this is
the main thing that would help is I mentioned when it finishes the glitch effect, it redraws the entire screen. And the way that you could make it work better is you work on the observation that the data that's being drawn is not random. It's deterministic. It's just a single chunk of the game code. And you know exactly what that pattern is going to be. And because all of the graphics on chip 8 are drawn in this XOR mode where you toggle pixels, if you drew the same animation twice, it would reset the ghost's appearance to its unscrambled appearance, and you wouldn't have to refresh the whole screen.
This is a little weird. It's hard to predict when the ghost is going to redirect someone up or down.
It should be clockwise,
Close.
so it's coming to you.
All right.
It's going left. It should be going up the next time it hits you. Yep. You had an object above it. The bottom of the grave was blocking it, I think. I think that's a blocker.
Yeah, that's the challenge in this.
That's a bummer. All right, let's move on. Let's get a game.
Okay, But for those playing along at home, I should have observed that there is an ending
Oh,
to
yeah.
this. So if you're thinking about trying this yourself, play it through to the end. There is a little reward for you.
Our next game is Horse World Online.
This game has the main thing that's special about it is that it was the first game that was completed. Tom was playing around. So Tom's wife is the lead developer on a game that shares the same title of this, coincidentally. That's about horse breeding. And Tom wanted to see if he could make a game that brought horse breeding to the Chip 8 system. And I think that this does a pretty good job of giving you a sense of what horses are like.
So is this a simulation then, and less gameplay?
Yeah, you can influence them to breed.
Oh.
But you know, it's a pretty simple game.
That is very interesting.
You heard it first from the horse's mouth, folks.
Probably the technical thing that I would point out about this is that about 2/3 of this binary size is the static bitmaps for the two screens of the horse talking to you. Just to give you an idea of just how much bitmap data takes up on this system. I feel like
that horse...
The whole thing is, it's 732 bytes, and it's not even 256 bytes of code.
I feel like that horse talking could be improved. Would there be a way to just have the mouth moving without it doing a full screen redraw? Because I think that would be a big improvement.
It would be possible to do that.
All right, let's move on.
Okay.
Look at those horses.
Snake. Yep, this is Snake.
Snake is always a good thing to say. Snake it makes me feel like I'm home when I see Snake.
It's the first game I ever made. It was Snake.
I think this was a good implementation of Snake.
It's a Snake clone. I made a Snake clone in Flash when I was 11.
It's a straightforward, solid implementation. So one of the things that's interesting about this game that's kind of subtle, and you can easily miss it, is that it actually renders text using a variable width font. So when you see the game over screen and the title screen, you'll notice that some of the characters are slightly wider than others. And that's kind of unique. Most of the text drawing routines that I've used in the past that are in the documentation are all fixed width. And I just thought that was a really nice touch. In order to use a single generalized text drawing routine that's repeated through the whole program, this author used a little bit of self-modifying code, similar to the techniques that are described in the documentation. If you're interested at all in trying to display text in your games, you should check out the source code of this game.
Oh yeah, the Snake has looping X and Ys, which I am not a fan of. I think that decreases the difficulty of Snake and sort of goes against the core values of Snake as a game. So I really can't approve of that design decision.
This is not Regulation Snake.
The other technical point that I should mention is that this game helped me find a bug in Octo's implementation, and that is related to the fact that it'll store your high score persistently. So the flag registers on the HP48 calculator were just sort of like general purpose settings storage on that platform, and the Superchip interpreter added the ability to access those, and you could save data to it. So Octo implements those using local storage in your web browser, so you have 8 bytes that you can just persist, and this game uses it for a high score table, which is probably a pretty good thing to use it for.
Yeah, it's smart.
Very neat. All right, moving on. Super Square by Tan. I play this a lot. I'm gonna admit I've played quite a bit of this already.
Super Square. This is a very
as a fan of Super Hexagon.
Oh yeah, this is a really solid implementation of Super Square. I think some of these patterns, particularly those U-shaped ones, are really, really punishing.
Yeah, there are very tight windows, and once you get, it doesn't take very many speed ups to get to the point where it is incredibly difficult.
So this game is one of the games that is requiring a somewhat higher runtime speed than a real Superchip system could use. It's using Superchip high resolution mode to draw. It's running at about 200 cycles per frame, which is about 10 times or maybe 7 or 8 times the realistic speed of the system. I worked with Tan on trying to optimize the line drawing routines this thing used, which is probably where it spends most of its time. It's somewhat challenging doing semi-general purpose line drawing like this.
Right.
Another thing that I should point out is that this actually has 16 different patterns that it uses to throw walls at you. And in the original release of this, there was actually a little bug where it would only generate 8 of them. This came from using the random instruction with an off by 1 error in the mask that he was using to select an offset into the appropriate drawing routine. But we got that straightened out.
Yeah, you found that bug, IJ, right?
Mhm.
So you, when you were overlooking that code, you actually noticed that it had 16 and only would show in game.
Yeah. It's a really easy mistake to make. Just needed a different set of eyes.
Well, maybe if there's better debugging options in the
I'm-
implementation of Octo.
Yeah.
Yeah. Whose fault is that, huh?
Mm.
All right, moving on. Breakout by Sharp and Spoon.
Ooh.
Notably the site's designer.
Right. So this was another game that he made as just sort of a playing around, getting used to how to work with the system. So this is running in regular chip 8 mode. It's running at a realistic chip 8 speed. It doesn't need any kind of complicated frame rate control code. It's just a really, really simple, straightforward implementation of Breakout. I compared it to some of the Breakout implementations that are in the wild for chip 8, and it actually is substantially smaller by about 30 to 50 bytes, depending on which Breakout implementation you look at.
Oh,
So
It's not easy.
I'm interested to know. So I had issues with this. The ball doesn't seem to have any difference in bouncing once it hits your paddle. Like it's
Right. It bounces deterministically, and I don't believe that it simulates having multiple angles that it can
Yeah.
fire at.
So I'm wondering if those
So
implementations that you say are larger have that, if that's one of the components that make them larger. Is this sort of
Yeah, most of them do. Most of them do have that, and another thing that's common is having like a score counter. But if you want just a really simple example to work from and see how it works, this is a pretty good one to read. It's fairly well commented. Probably the main question that most people would ask about how this works is how does it keep track of the bricks and how does it track collision? So what this is doing is it starts by just drawing all of the bricks in the places that they should be. And then the game doesn't keep track of anything more than what is in the frame buffer. Whenever you draw a chip 8 sprite, if it flips pixels that are already set, it will set the VF register, the carry flag. And you can test that to see whether or not 2 objects collided. So what this game does is just if the ball is moving and it's on the top half of the screen and it collides with something when it's drawn, then it knows that it collided with a brick somewhere. And if you just round the horizontal position of the ball, then you can figure out the starting horizontal position of that brick and just erase it.
that is fiendishly
I don't know
clever.
if anything actually. Yeah, I don't know if anything actually happens if you destroy all the bricks.
I don't believe it does. At least,
Well, good, because it's not going to happen.
I mean, you know exactly where that ball is going. There's no like tricks to it, John.
Right.
I'm serious, Everdraed.
I
You
did-
should probably play this
I
and understand my
played
pain.
it and got to the state where it had no bricks left, and it didn't do anything. So unless there's a newer version, then I'm pretty sure nothing happens beyond that.
If you move while the paddle collides with the ball, it actually slides right through.
I don't remember that being an issue, but I think I was very precise with my paddle play. I'm a big breakout player. I sort of broke out.
This is sort of an art game, guys. It's making a statement about the futility of playing Breakout.
Gone home, eat your heart out, man.
Yeah, I think it's
This is teaching me things about myself.
my one issue, as I said, was that I would have really liked to see different like sections of the paddle causing different amounts of velocities in horizontal and vertical movement of the ball. That by itself, being able to aim the ball by positioning the paddle is a huge aspect to Breakout. It would have been nice to see, but I think this is a really great implementation of Breakout, simple as it is. That
All right,
that
moving on.
method sounds
Oh,
smart.
go ahead.
I was just saying that the method of rounding to figure out the positioning of blocks, it was particularly intelligent. That was a good way to do it.
I just noticed the name is Breakout with 8, because chip 8 Breakout.
Yeah, it's subtle.
Very clever.
So it's break out.
Turnover 77.
Turnover 77. This was another
Oh,
real
this was-
standout. This is an adaptation of a well-loved indie game.
This is probably my favorite game. It is good.
It
It's
is
one of
really
the most
hard.
gifts in the IRC channel while it was in development.
So me and Tan, we played this for I think a few hours, speed running this game to try to get like the fastest possible run, and we got about I think as good as you could get on this map. Now,
I think people were placing bets on how long they were taking to beat this.
I bet, or I didn't bet really. I had a certain guess of how far you'd be able to get during the playtime of you streaming. So my guess was to the bottom left corner was about as far as you would get.
I think that if you don't finish this, John, we should stay on after we've looked at all the other games, and you should stream this until you get it. I want to make a montage of this.
Oh, you're proving me wrong.
So close.
Ah!
So this
damn it.
game uses Superchip high resolution mode to draw its graphics. The whole level background is a full screen bitmap, which means that takes up an entire kilobyte of space. I looked through the code to see how much space was left over, and there is about 1,400 bytes free. So it might have been possible to add another level to this game.
I think it would have been nice to see another full map for this.
I can only imagine how long it would have held you and Tan's attention trying to speedrun it if it had
Well, that's
twice
the
as
thing,
much
because
content.
it's one map. It's really speed runnable. If that's a word. It's it's enjoyable to play this game. And what I thought was really incredible about this game was that I was aware of the indie game that it's based on, and I haven't actually played it, so I should play it. But just by the fact that game is 3D, there's issues of knowing exactly the hitbox of your limo, which is constantly rotating around, right? So that's a 3D implementation of the mechanics that you see in this game. And this is a 2D implementation. And this is notable because you have pixel perfect accuracy of what you're hitting. You can see by the change of color of pixel exactly what touched what. And so the fidelity of knowing where your mistake was is kind of huge. Like, that is really, really important to me. This 2D implementation of
that pixel perfect collision is one of the things that Chip 8 is really good at doing from like a programming language standpoint. And in more modern games, it can actually be kind of difficult to achieve that. So it's interesting how many of the games that we've seen here and that can be found in Chip 8 games in the wild took advantage of this somehow to make their gameplay.
Yeah, once you get a feel for where the pixels of your line is, there's some incredible clarity. Like, you can brush and skirt along edges incredibly well and know, with certainty. And you can see, like, watching him hit something on accident, you can see those exactly where he's hitting it and realize that, I needed to press down one more time. I need to press right one more time or two more times and know, like, that's how I have to do this in the future. That's huge. That feedback, it's like a feedback thing that works incredibly well because of the native sort of hit detection of the pixel of Chip 8.
This is one of the games that runs a little bit faster than a realistic speed. But what's interesting about this is that, once again, this game actually would work at an unmodified speed on the real machine, aside from the fact that it needs the overclocking for a special sequence at the end of the game, which we might get to see if John succeeds.
I don't know. I don't think he's gotten past halfway, and it is kind of tough. So I would like to point out that the map design is actually kind of devious, especially the end section. The way it's set up with pacing of how your of cycles of your turning sprite. it actually tries to trick you. It tries to make you think that you'll be able to make something when you really can't, and you need like to lead up into it. So I thought that
Trying to
exactly
goad
it's
you
taunting
into
you.
taking things a
It
little
makes
too
you
early.
think that you can, get to that final curved hook section in one cycle, but it really is not possible. So I thought that was really kind of clever. Like this map, I'm not sure how long they spent on making this map, but I feel like a good amount of time went into crafting this map, and that's really the intricacies of this map is what makes this kind of shine. These mechanics. I would like to point out that I said earlier that me and Tan played this for a few hours. We were speedrunning this, and we got down to I think I was just barely able to get the better time of 31.9 seconds, and that's sort of abusing the mechanics of this game. So you can take 4 hits, and on your 5th hit you'll reset. But you can be in a wall for 4 hits, 4 frames, and be okay. So these 2 thickness walls that you see that's directly in the center of this map, that 2 thickness wall, if you approach it while you're going vertical on your sprite, and you force your way through it, you can actually make it through in 4 frames. So you can actually go above that circle in the top center, and then right as you go vertical, skirt right through it on the right. So I'm going to suggest John trying to do that because he's having difficulty. The thing is that makes the rest of it more difficult because you can't have any sort of mistakes. So that uses all 4 of your chances. But for a speed setting where you're not trying to hit it at all otherwise, and you've already kind of learned the map, that is extremely useful for going quickly.
The other thing that I should point out is that on the Chip 8, graphics are always drawn as if the screen is toroidal. That is, sprites will wrap around vertically and horizontally. So that means that if you look at the right and left side of the screen, there actually is a 2-pixel barrier between the far left of this playfield and the far right. So it's also possible to warp through there, although I believe you and Tan found that didn't actually help you very much.
So the one that I suggested at first, which is what he's trying to do right now, that wall clip will get you around 38 seconds, I believe. So that's a fairly good wall clip, but there's actually a better wall clip. The better wall clip is to go through the entire route up into the bottom center, and before you go through the one-line segments, right below that right side first line segment, you just face through that wall, and then you go into the hook. Oh, he got it! So now you can't make a single mistake after that point. So that one is that one when you have a pretty good ending cycle hitting the final goal, that's a 31.9. Now, if you take the spot, that's the bottom 2/3 of the map on the left, right on the leftmost square in the circle roundabout. If you go left from there, and that requires incredible timing because you have to go skirt underneath that block and be vertical with your sprite. It's very difficult to get that dead on. So if you do manage to do that, go left from there, you'll come out on the other side, but that will end up being about the same cycle. So both of those methods, they're about equally as good, but that one's more difficult to pull off. So you'll get 31.9 with both, generally.
So how would you say your blood pressure's doing right about now, John?
Yeah, this game is probably my favorite because it was speed runnable and it felt really immediately approachable. Like, I really like how the mechanics, the feedback that you get from the core systems, the collision of Chip 8, it works really well.
Do you think that if you were in 1977, would you have been willing to press 2,144 hex digits into a keypad to be able to play this game?
If I knew what I was getting to at that point in time, yes, I probably would be. Mostly with the notion that I would make my own maps, because I'd like to see.
Yeah, that actually would not be very hard. The way that this game is written, like I said, the map is basically just a full screen bitmap, and one of the development tools that's in the Octo GitHub repository is an image converter that'll let you just take a 1-bit bitmap and convert it into a hex format that can be drawn here. So it would actually be possible to just use that utility to convert your own map and plop it right in.
Oh, we should totally do that. We should totally make some maps
to the
for this
existing
then,
game.
because I think I'd love to see.
That might be fun.
If you could I mean, it sounded like you needed a kilobyte to get a full map for this, so if you could fit one easily in and make 2 map screens, that'd be amazing to see.
I think that'd be pretty easy to do.
I keep like every time I make a mistake, I just reset myself because it just doesn't
Well,
feel right.
if you make a mistake, you can't do the wall skip. But the wall skip, pulling off the wall skip is difficult, and if you don't know how to do the final approach anyway, it might be kind of difficult to do that as well. So as I said,
I've nailed that first turn. I feel like I nailed it.
You did well. You did well.
But
You didn't
this
nail it. You
wheel
could have been
here
tighter
is-
on it. So it actually doesn't matter. The way you got it was as good as you can get it. The cycles line up where you can't, even if you're perfect, you can't get under that first dot, which is sort of sad. I think this map could actually be tweaked to be a little bit more friendly to like absolute perfect play. It would be nice to see like if you're perfect, you could get through this on like one cycle, like not needing to wait. But that's a hard design to pull off, and I think they did a good job with this map in general.
As far as mods and remixes are concerned, it's very easy to do that because all of the games that were created in this jam are open source, and you can use the
Well, I
tools
guess it'd be
right
kind
in
of
the browser.
cloning the indie game at this point. I would have loved to see like a more advanced 2D version of this game actually done as like a $5 game. That'd be really impressive to me.
Now's a good time as any to go over what Chip 8 is and how people can get involved.
Okay. Well, so Chip 8 is basically a virtual machine that came on the Cosmac VIP microcomputer that was sold by RCA. So it was a very, very limited system. It had a slow CPU based on an architecture called the RCA 1802, and somewhat difficult to program. So in order to make the system more accessible, it came with this program you could load called Chip 8 that would let you write programs in a more convenient, still machine code-like language. And Chip 8 handles the things like sprite drawing and using the Cosmac VIP's graphics hardware and everything. So it vastly simplified programming for the system. And the other thing that was good about it was because it abstracted all of these really low-level details of the system, it made it possible to make games that were portable between computers. And the idea of just portable video games was something that was very uncommon at the time. There were some games that were written in BASIC, but BASIC was a comparatively heavyweight language. You'd need to have 4 or 8 kilobytes of RAM to be able to play with it at all. And with Chip 8, you can make decent games in a few hundred bytes of RAM. Even if you only have a 2 kilobyte system, it's still usable. The Cosmac VIP died out after a few years, as happens with computer hardware, but this portable virtual machine stuck around, and it was ported to graphing calculators, like I mentioned. It was ported to all kinds of other systems, and it became sort of like a rite of passage for people who are interested in emulators to write an implementation of Chip 8. Oh man, you're so close.
Too bad.
This system has been around for a really long time in one form or another, and there are a collection of maybe about 150 games in total, or programs in total, that run on the system. You can find around on the internet in archives, like if you check out chip8.com, there's a big archive of everything that you can download. But something that I found was there weren't very many sophisticated tools for trying to author new games for this platform. So I thought it would be fun to try to make like an SDK to really make programming against the system accessible and fun, easy to get into. For a variety of reasons. I think it's fun for people to be able to play around with assembly language and learn about low-level programming, but have some interesting things that they can do. You can do graphics, you can do very simple sounds, you can create interactive programs rather than just, at best, writing an assembly language program that prints out some numbers. So Octo is a browser-based editor. It lets you write your programs in what's called a high-level assembly language. That means that you can use structured programming constructs like if statements and very simple loops. And you don't have to write spaghetti code, but you are still writing low-level code. You're thinking about what goes in registers, and you are in complete control of every cycle that the machine uses. So I think it's a really fun educational tool. most of the people who have tried it have said that they found it very easy to pick up. And in the future, I'm actually going to be turning it loose on some middle schoolers and high schoolers, and some community outreach programs that I'm associated with. So if you're at all interested in the games that you've seen here, you want to try tweaking them, or maybe you want to try making your own game from scratch, if you just go to Octo-Jam.com, you can find a link to the Octo IDE itself. It gives you the ability to share your creations with others and give people a URL that just drops them into your game and lets them play it. There's tons of documentation available online, and since we had a pretty good turnout this year, we're going to try to hold another Octo-Jam again next year. And I'm going to continue working on these tools. So I think next year there'll be some new fun extensions to Chip 8 to play with, as well as even better tools.
You plan on implementing anything that'll bring it actually beyond Super Chip, or is that going to be pretty much the plateau of keeping it in line?
Well, what I'm going to be doing is adding a handful of special instructions. They're actually available to play around with right now, although they're still sort of being tweaked. My plan is to make it so that you'll have some sound capabilities, because there are a number of people that wanted to have some kind of special sound effects or music in their games, and it'll expand your gamut of colors from 2 to 4, which I think, yeah, I know. It'll allow you to make things sort of like Game Boys, and I think that just the addition of 2 more colors will make it possible to make all sorts of new interesting games, like puzzle games that require colors. Things like Dr. Mario or Puyo Pop are very difficult to do in just 1-bit. And so if you want to be a purist, you can program using just the original instruction set and the original speed requirements. But if you want a little bit more, you want to make something that looks a little bit fancier, you can use some of these extended instructions.
Well, I respect you doing that, IJ. I think you're getting a bit extravagant, and you're sort of, I think you're taking video games in the wrong direction. This focus on graphics, four colors.
I'm mad with computing
How could any person possibly use that in developing a game? That seems way too much. It's difficult enough choosing 2 colors. 3 and 4 just kind of, it makes me a little bit queasy. With the choice, and it's unnecessary. So I can't encourage that. But I think it's great stuff that you're doing. Yeah, I don't know how long people can watch you play.
Alright, we need to move on.
I mean, to be fair, me and Tan did play this for hours. So mission accomplished. You got people to play it for a long time.
Okay, and this is also
what the hell is it?
By your name here, also known as Dr. Stab. He's the guy who wrote Turnover 77. This game was made, as the description says, in a couple of hours the night that we were closing submissions. And this is Ultimate Tic-Tac-Toe. The idea of Ultimate Tic-Tac-Toe is that you're playing 9 games of Tic-Tac-Toe at once, and it doesn't, the individual games essentially tell you who gets an X or an O on the larger 3x3 grid. I think this is the only 2-player game that we had.
If you're confused about having to do both, it's because it's 2-player job. I'm afraid this is only local co-op, which is a really that's a pretty huge downside to Ultimate Tic-Tac-Toe. I would have liked to see some sort of online co-op in Japan. How many years was it before they had any sort of online co-op to exist after 77? Is that
I have no idea when the first online multiplayer.
I think that's still a few years away. I guess there's probably some early BBS based mod would be my assumption.
Going back
to playing.
Yeah, so I mean, as I said, I thought Turnover, especially once you get into the arms race of trying to speedrun this game for the fastest possible time by wall clip, this game had some legs on it.
There is one more game to look at.
Is there?
Yes, it's System Logoff's Rock, Paper, Scissors game. Told you he submitted 3 games.
I would like to say that Turnover 77 probably had the best ending scenario / Easter egg of any game that I saw. I think.
So RPS is a very straightforward rock paper scissors game. It's got great graphics. I think it makes amazing use of what's possible with just the unmodified chip 8 graphic settings. It runs at a realistic speed. So what I should mention is that this is one of the games that has an ending sequence. It will give you a special Easter egg if you can manage to score 100 points.
Is this something other than random? Because this felt pretty good against me compared to what a lot of usually you play like a random tic-tac-toe, so you win half the time. This felt like something other than random to me. Can you say anything about that code-wise, or was it just random and I didn't notice? Okay.
I think it is actually random. Go ahead and check.
It's running so fast.
Okay. Yeah, I guess
Yeah,
I'm just mistaken
it's completely
that I
random.
didn't play enough games. I think I played maybe 20 of them, and it felt like there was some sort of predictive.
Wow.
I remember to slow it down, forget
You've
near
really
the end, so we see
transcended this
the
game,
whatever
John.
ending it has in a normal.
I don't know where they store the default score.
Another important thing to note is that all of these programs are open source. If you'd like to change them, see how they were done, get some ideas, comment on people's code, harass them about their coding practices, be an asshole. I mean, these are all possibilities that you can do because of the Chip 8 platform in Octo. So, have at it.
See, I'm demonstrating the wonderful uses of
this is the leisurely. Ooh, plus 99.
open source code.
Well, maybe you shouldn't be a cheater.
It only gave me +3.
What you need to do is if you go to the very beginning of the code where it says main, if you immediately call the subroutine "Oh God," then you'll get the special ending. It is
well commented. This code is very well commented.
I think in general the submissions were all pretty good. It's for the most part they're quite nice to read, and so anybody who's interested in this at all, I would really recommend, even if you don't feel up to the task of making your own new game from scratch, poke around and look at the source to some of these games.
It was 1,000.
Well, the comments in it are saying 100. I think it might actually happen when it wraps around.
Well, it makes sense to happen on the wraparound.
Well, I think that's a pretty good place to wrap up then. I think we should all go outside after this.
Well, it's kind of dark and cold now. It's, at least for me, because I live in a void.
So overall, what do you think?
I think it was a
let's
fantastic success. If I had to say anything, it's
playing.
how many submissions was that for, as far as games being submitted to October?
That's a total of
like
13 submissions.
Nice. Yeah,
I think considering how niche the idea of programming your own homebrew games for a really old game system like this is, I think that we had a great turnout. And I hope that if we do this again next year, we might see an even bigger one.
Yeah, I think going forward, this was obviously done sort of on a short notice. We were working on Octo right like up until the point where we decided, hey, this is working out real well, right in time for October. Let's see what the jam.
Really, it was a pun-driven organization thing.
Yeah,
because we realized that October was the ideal month to do it.
Sometimes something is so spot on and clever, you have to do it, even if you have only a few scant hours before it has to be done. But yeah, I think it was great to see these games. I mean, some of these games, especially Turnover, especially the Glitch Ghost, those games, both of those were extremely impressive, and I think it's really incredible to see people making such compelling games with really tight mechanics that take natural use of Chip 8 and its strengths. It's just great to see people able to make this sort of stuff.
I think so hopefully all of the submissions were creative and interesting, and I think that everybody who participated should feel pleased with their work.
Oh yeah,
for sure.
I mean, I'm impressed by every single entry. I was just noting those two because they seem to specifically. They kind of impressed me beyond any sort of expectation of what a Chip 8 game could be. In the sense that, these are not super complex games, and they're super limited to what you can pull off. But these are like novel. These are novel ideas.
I think that what you can say is that these games are fun, not just for Chip 8 games, but as games in their own right.
Yeah. It's not just, this is a super limited platform. is incredible they even got something workable. It's, these are solid games that were designed with these limitations, but still, they're fun in their own right. Not just because, they're impressive on a technically limited setting.
Do you have anything to add, John?
You haven't beaten this yet, have
Playing a game. Don't bother me. Yeah, I didn't really participate because I was busy.
So yeah, we'll have to hype it up more.
Is my jam, quite literally,
for
no
next jam year. But yeah, great to see people doing this stuff. Will John beat this game?
Yeah, great. Everything's great.
It's getting close. This might be a long night.
The stream doesn't stop until I stop.
Okay, well, I'll just go ahead and say thanks for sticking around. Thanks for watching us. We'll probably have John continue going here, and maybe we can edit it down into a tearful montage with some action music.
Oh, that'd be great. It's too bad we don't have a face cam and him like sort of taking breaks and working out, chugging like a big glass of eggs, and just sort of doing that thing that Rocky does to get pumped up.
Thanks for watching. Thanks for watching a couple of games with us and maybe learning a little teeny bit about retro game programming. I've been InternetJanitor.
And I am Everdraed, who at one point was disguised as InternetJanitor.
A person named John Turner. Playing a video game. Thanks for watching.
Now you gotta beat this game.
You gotta win now. There's also you're the best.
Or you spin me around. What? Oh.
What?
No, you're not supposed to hit the words. Not the words.
You hit the arrow. I did the same thing, and I actually thought that was the ending because so I got to the end. The first time I almost beat this game, I got to the end and I hit the arrow, and I'd done it enough that I had not been hit once before. So when I hit the arrow, it made a flash of like 5 flashes because I used all my hits. And I thought that was the win state of victory, was seeing those flashes on the screen. But that was just damage. So yeah, you have to hit the goal circle, not touch the arrow, or you lose.
There is enough memory. Like even so, you could have 2 screens worth of tiles, which would represent like quite a few pieces depending on how you cut it up, and you'd still have a couple hundred bytes in addition to that to add the necessary code.
Yeah.
Okay, now you gotta be fast. You gotta be ready. This is important, John. Have you ever played Desert Bus? Because you are now.
Oh,
you gotta get a point.
God damn it.
This is such a great implementation. I love that this is the Easter egg payoff. Is you get the Chip 8 version of Desert Bus at the end.
And this is the reason that the game is clocked as fast as it is. It's purely to be able to update those digits on the bottom of the screen. Nothing else in the game needs the extra speed except for that. Because if you slow the game all the way down, you can see it's redrawing every single digit every time. Which also makes me wonder if he was a little bit more selective about only redrawing the numbers that he needed to. Maybe he could make it run on a real chip.
Maybe you'd be able to cut it down so you'd have to do like 0.2 or 0.3 updates, but that would be fine. Honestly, I feel like, the split 1/10 of the